Hello everyone. I'm gonna say October, November the 5th. Oh, I have another easy one today. Arranging coins. I've done it before, back in July 2020. Okay. You have n coins and you want to build a staircase with these coins. The staircase consists of k rows, and the ith row has exactly I coins. The last row may be incomplete. Given the integer n, return the number of complete rows of the staircase you will build. Third row is incomplete. So the last one can be, last one can be anything. So basically the question is, given n, we need to do 1 plus 2 plus 3. So maybe there's a math solution to this. So what do? We say 1 plus 2 plus plus the answer, whatever, let's call it x. So 1 plus this, and then plus the remaining, right? The remaining has to be, so we have a total is n. So this n minus this shall be smaller or equal to x plus 1. Right, so we just solve this to see what is the n for this. Let's see, so x plus 1 times x divided by 2, n minus this. We know n smaller or equal to x plus 1. So we're going to do 2n minus x squared minus x, 2x minus 2. So 2n smaller or equal to x squared plus 3x minus 2, right? Which means we can do x squared plus 3x minus 2 is largely equal to 2n. So we get n, so we get this value, and then we need to find what will be the x, right? The number of rows. Isn't this like deterministic? So let's n is 5, right? N is 5. N is 5. Hold on, this doesn't feel right. There's a total number of coins. And then the last one will be x plus 1, which means this, yeah, this is right. So let's say n is 5, then I have 10. Right, so it's x plus 3x minus 12 largely equal to 0. Well, if x is really huge, this will always work. Oh, larger equal to 0. Yeah, that's larger than 0. So larger equal to 1. It cannot be 0. It be larger equal to 1. Yeah, I forgot about that. Okay, so we're going to rewrite this. N minus x squared plus x smaller equal to x plus 1. Right, then this gives us that. And then this has to be also larger equal to 1. 2n this minus x larger equal to 2. Right? So we have 2n is larger equal to x squared plus x plus 1. So we have 2n is smaller equal to x squared plus 3x minus 2. And 2n is larger equal to, so these two must be equal. So x squared plus 3x minus 2 is equal to x squared plus x plus 1. So we get rid of these. No, that doesn't make any sense. Hold on, how did we solve this last time? It should be very straightforward. I thought a math solution will work. Why does the math solution does not work? Yeah, it must be something is not right. Let me try it again. So we have this, right? This is the number of coins on the last row, and we know the number of coins on the last row must be smaller or equal to x plus 1, right? Otherwise we can always increment x. So this one will give us That's x, 2x plus 2, right? So 2n will be smaller or equal to x squared plus 3x plus 2. Okay, that's first mistake I saw. All right. So we also say must be larger or equal to 1, right? Because if it's not larger or equal to 1, then yeah, we have the larger equal to 1. So this one will give us larger equal to x squared plus x plus 2. Right? So if we get 10 inside, so we have x squared plus 3x minus 8 should be larger equal to 0, and x squared plus x minus 8 need to be smaller or equal to 0. Okay, how will this help us? So we say x squared is larger or equal to 8 minus 3x, and x squared is smaller or equal to 8 minus x. X is larger than this value, but it's also smaller than this value. Smaller or equal to. So x has to be we just pick x, right? We pick the x from a 1. 1 doesn't work. 2, 3 works. No, 3 doesn't work. Output is 2. 2. Does 2 work? 2 works. Yeah, 1 work. All right, 2 works. Yeah, it does work, but yeah, I thought I can get a straightforward answer to this. I mean, maybe we can mathematically. I mean, we can definitely just do it, run a loop, right? I can easily run a loop, and then once it explodes, then we say that. But I want to try to see if a math solution will suffice. But I don't seem to be able to. The math solution still have to do a loop. Like, it doesn't give me a straightforward solution. Hold on, maybe I can. What if I just try to solve this problem? We try to solve x times x plus 1 divided by 2 equals n, right? We try to solve this problem, and this one will give us, two values, right? Will give us two values. The minus 2n equals 0, and then we can solve this, and then let me see. If we solve this problem, x squared plus x, so that's here, right? If x is 0, it's going to be minus 2n, right? And this one has a minimum value, right? Have a minimum value, and x 0, so it will be something like this, right? Yeah, it will. The minimum value will be negative, something negative. So it will be it's a parabola. It's a parabola. So I'll have on a positive, it will be one root is positive, one root is negative, and we can always for AC for 8n, right? So we always take 1 plus an minus 1 divided by 2. That is the root. So we have the root. That means, right? That means that will make it work. And we need an integer. So we just take the integer of that. Let's try the first one. We take the integer of that. So we take square root 1 plus a times 5, right? Minus 1 divided by 2. We take integer, that is 2. The second one, again, so we say square root 1 plus 8 times 8, right? Then minus 1 divided by 2. Take the integer, that's a 3. And if it works, then it will just be itself. Let's say 8, 9, 10, right? Let's say 10. So if it's a 10, that's 81. 3 is a 9. 9 minus 1 is 8, so that'll be 4. Yeah, I think that should be it. I think what I just need to return an integer, math.sqrt, so square root 1 plus 8 times n, right? So this minus 1 and divided by 2, which I can just do this. Divided by 2, isn't that right shift to 1, right? Right shift to 1. That should be it. Oh, that gave us this, all right, so that is not. So we do have to take an integer. Then, if that's the case, then we just, that's just, we might run into some issues. So let's just divide it by 2, right? No, I don't like it. I like to do integer at the end. Yeah, I think this is the safest, just in case. Right? Safest, just in case. Yeah, let's see. This one shall be right. Yep, it's much faster. Right? So I think the previous solution I have is just loop. A loop does work. Right? Loop does work. But solving it in a math formula is easier. Not easier. It took me a while to figure it out. Oh, it's the same. I used the exact same solution back then. I thought I was using a loop. Square root 2 times n plus this minus, oh, I think 2 times n, oh yeah, that's the same thing. Same thing. But why is this one faster? Doesn't matter. Alright, so in this case, then I have to write the solution in the other format, the loop format, right? Okay, let's write it in the loop format. So again, we don't need test case. This is solution 1. Yeah, let's do solution 2. Let's also record it. What's this? LeetCode. 441, right? 441. Let's also do the res, right? Res equals 0, right? And then we are going to say while so we need to have a sum, right? Res, and then we also have a s, just like a sum, and shouldn't res start with 1, right? We say while s is smaller or smaller than n. What if it's equal to n? Equal to n, yeah, it should be smaller than n. While s is smaller than n, res, s plus equal to res plus equal to 1, right? So, oh, we could have 0, I think. Oh, we will not have 0. N is 1, so I can start with 1. Everyone start with 1. The 1 is smaller than this. Then s will plus equal to Nah, s had to start with 0. Right, so s is 0, and then we'll add 1. Rest become 2. Coming back, this will post 2. Right, and then until one time that s is either equal to, or so yeah, currently is this, right? And then we want to add a next one, s plus, going back, and then breaks. So that should be smaller equal to, because we can do equal to. So in the return actually rest minus 1, right? Because I already added and then break. So let's try this. What? I already minus 1, still now, hold on. S is 0, right? So s is smaller than n, s plus 1, so now it's 1. So I do this, and then rest goes here, right? And then coming back again, s is smaller than n, now s is 3, rest is here, 3, right? And then coming back again, s3 is good, so s is going to be 6, right? S is 6, and the rest comes here, right? Rest is 4. Going back, 6 is still smaller, and then we'll add the next one, and then rest will go to the next one. Maybe we'll just start, everything start with 0, right? Well, start with 0 should be right. So start with 0, so now rest become 1, comes in here. Well, that's the same. So how should we do this? Like every time when we add it, we should add the exact thing, right? So I think if we add rest first, everybody starts at 0, right? So rest will become this, s becomes this. So they're at the same level. Coming back, rest and s the same level. Coming back, rest s the same level. Coming back, rest become here, s become this, and then yeah, this one shall be right. Change the order. Yeah. Oh, wow. If you do this, it's much slower. I see. So this is a iterative, right? Iterative. Then this is math. Okay. Take a look. Oh, binary search. Ah. Howdy. I forgot about binary search. Yes, we have current. Oh yeah, binary search. We have a lower bound, we have a higher bound. Higher bound doesn't matter, we can put any higher bound, right? Higher bound will be, yeah, that's a good higher bound. So we pick the middle with a total sum. If total sum is too big, then the right, otherwise left. Ah, that is true. Yeah. Let's write it. Yeah, I didn't realize you can do binary search on this. I just think, okay, I'll just iterative is a binary search. So we have low, high equals low will be 0, high will be n. Yeah, because it will definitely be smaller than n. So n is a good higher bound. I'm going to say while my is low smaller than high, and mid equals low plus high divided by 2. And then if mid times 1 plus mid divided by 2. That's the total. If this one is smaller than n, right? We're gonna say current. Right. Current of this is smaller than n. Then what? If it's too small, too small, so the low can move higher. So low equals to mid plus 1. Otherwise, if curl is larger than n, right? It's too big. Well, it's too big, then high will equal to mid. Actually, I think this else should suffice, right? Else high is this, and eventually they will meet each other. That will be the time that I'm not sure. And then we return low because they will get out. So smaller, and then it will be bigger, and then they're just adjusting. And at a certain point, current is smaller n, low, mid plus 1, and then boom, this one jump out, right? Okay. Let's try this. Right, quite straightforward. So what we have 5, input 5, expected 2, right? The input 8, expected 3, and input 10 should be expected as 4. So we give these, see how the binary work. What the hell? EOL while scanning string literal. Oh, we have 4. Nope. It's too big. 1 too big. That's interesting. Alright, so let's see. We have 0 and 5, right? We start with 0 and 5. And then 0 and 5 will give us 2. So mid will be 2. 2 times 3, that will be 3. 3 is smaller. So low is mid plus 1. Oops, mid plus 1, that becomes 3. And 3 times this, mid is 3. So 3 and 5 give us 4, right? 3 and 5 gives 4. 4 is way too big. 4 is 10, so 4 is too big. So high equals 4. Now we have 4 and 3. Come back as 3. 3, that's still too big. Wait, hold up. What did we go wrong with this? We start at 0 and 5, and the first mid is 2. But 2 times 3 divided by 2 is 3, which is small. So low, we should not go low, mid plus 1, right? If low, mid plus 1, we will miss the point. If we want something that's smaller than n, right? We want it to be smaller than n. The largest mid that can cause current smaller than n. So when that happens, we can push the, let's push this down, and let's say current equals, right? Let's say current equals. Now this one give us, now this one is not working. Why is this one not working? Again, mid is 2, and it's too small, so low equals 2. Alright, so high is 5. Going back in, 5, 2 will give us 3, right? So current will be 3 times 4 divided by 2. That's 6. That's too big. So high is too big. High will equal to mid minus 1. So 3 minus 1, that becomes 2. So this one will come out as 2. That works. So I think it's not these two. No. So I think the first one does work. Yeah. So it's the second one. Okay. So we have 8. So first round gave us 4. 4 is 10, too big. Right? 4 is too big. So we go to 3. Right, now we have 0 and 3. 0 and 3 give us 1. Right, so mid is 1. And 1 is way too small. So low equals 1. So it's 1, 3. 1, 3 give us 2. 2 is too small. Yeah, 2 is still small. Right, so low equal to 2. Now it's 2 and 3 become 2. 2 and 3 becomes 2. That's why it's not working. But we have to bias on the low. We have to bias on the low. So yeah, this is, we have to bias on the low. But if we bias on the low, the value come out too big. So why would it be too big? Because it's still smaller equal to, right? The current mid is still small, and then plus 1, then we meet this come out. And high is always bigger. So that's why it'd be low minus 1, right? But if we do that, the temp4 will, the temp4 still pass. Hold on, we don't do this, temp4 also pass. Huh? Oh, smaller equal to, that's the case. Smaller equal to, because this one will be equal to, and I still do, so we always bias forward. So at the end, we need to get out. Okay, this one works. This one works as expected. Good binary search. Oh, I just said it works and then does not work. Input 1, output 0, expected 1. Input 1 shall be 1. What is this? Input 1, 0, 1 give us 0, right? 0, 1, mid is 0. This is a current 0. 0 is smaller than 1. So low equal 1. Come back. Oh yeah, that does return 0. Ooh wee. How does this work? Huh. Mid is 0. That is the issue. Mid is 0. And 0 smaller equal to this. Then coming back. Yeah, n has to be high. Has to be larger in my case, I think. Yeah, because if n is equal to high, then n is equal to high. Yeah, because what we want is at the end when low comes out, we want the low to be like biased, to be like on the right side, right? On the right side. On the right side of the correct answer, which means the high has to be larger than the correct answer. But if we start with n is the correct answer, then it will never reach it. Therefore, but if we plus 1, that shall work. See, binary search is never easy, right? It's never easy. It always have these edge cases. It's hard to realize. So probably have to write something here. Note that high must be larger than n because high must be larger than the correct answer. Since n can be the correct answer, e.g. n equal 1, we must make high larger than n. So yeah, that's that. Well, it actually take way longer than I wanted, but it's good. All right, I said I don't want to do another one, but yeah, tempting. I mean, we can do another easy one. Yeah, we can do another easy one. We don't have to do another medium one. It might take longer. I have something to do at 1 o'clock. I have half an hour. Let's do some easy ones. It's Friday, all right? It's Friday. Let's have some easy ones. How about this? Binary tree pre-order traversal. Oh, how about single number? How about we do both? We're just like, it's an easy fest, right? We treat today as an easy fest. Let's see. Pre-order traversal. No, I have not done this. Why do I click it? I picked this because I have not done this before. Pre-order traversal. Wait, what's pre-order? I forgot. Wait, is that node left right? Is that pre-order? Node left right. Node left. This is a stupid question, but what is pre-order? I never really liked the name. Right, so in order, pre-order. What the hell is that, right? Just tell us which side it goes first. All right, a pre-order NLR. I think it is. It's the root left right. Right, so it's root left right. Yeah, I don't even want to open it. I think at this point you just go. Oh, we want to produce a list. I mean, the easiest will be just have this, and then we do DFS. Can we return it? Now that's the challenge. I mean, because if we do this, tree node, right? And we can just say, okay, we do this. We say if node. We can do res.append node.val, and then DFS node.left, and then DFS node.right. Then we're going to call it DFS root and then return res. I think this one shall work, but kind of like, no, is it using global variable? That's not a global variable, but is it possible to do this directly? Like, can we do it? Well, I mean, every time I can pass in. Let's see. What if I pass in a? Let's take a path. Let's just do a path. It's going to be a list, right? List of integers, and we just say if node, right? If node, we but everything has to return a list. Then we'll do the list plus list. Let me see. Node. I can put node into the path. Left and right. Hold on. Am I not? Let me think. Okay. If not node, right? If not node, we definitely return empty list. Otherwise, we are going to say left equals self dot preorder traversal root dot left. Right, so this one gives us the preorder of the left, right? And then we can do the same thing for the right. Right, we can do the same thing for the right. That's the preorder of the right. And then the middle will be return root.val plus left plus right. This will not be any faster, but I think this is correct. Name node is not defined. Okay, this is root, it's not node. Yeah, but this one will be slower because we have this. Slightly slower. Okay. Yeah, that's it. Right, that's it. Yeah, kind of too lazy to do, but I think we should still mention it. 144, right? LeetCode 144. So we're gonna put both solution up. So that's I call this, it doesn't matter. I call this solution 1. So the LeetCode 144. This one give us, what's the time? 32. 68. And we have another solution. I can actually just write it. Right, this is another solution. This one is 28. 28. DFS node, optional tree node, and then nothing. If node, rest.append node.val, and then DFS node.left, DFS node.right. Call DFS on root, and return rest. Right, let's see. Yep, and this one is 87. Okay, so that's that. All right, let's do the last one. Single number. All right, what's the single number? Non-empty array. Every element appears twice except for one. Find that single number. Linear runtime. Then use only constant extra space. Find a single value and everybody else is double, right? Yeah, I think use constant extra space. This is something, if it's not constant, that will be easy. We just throw a counter at it and then we're done. Constant. How do we handle constant? So when we traverse through, so we have 2. How do I remember a 2 already exists? Each element appears twice, except for one element which appears only once. So we traverse. That's an interesting question. Actually, I don't see it immediately. constant extra space. How do I check if I have encountered this one before? Well, everybody appears twice, right? Everybody appears exactly twice. I mean, how about we take the sum of everything, right? We take the sum of everything, and if it's an even number, let's say the sum is an even number, like here, it's 5, right? It's an even number, so we know that the singular value must be an odd value. So we go through, if it's even value, we just ignore it, even value, we ignore it, and I don't think so, because we have multiple odd value. We have 3 and 3, right? We have 3 and 3. There we go. And this will be 5, it'll be 8, and the 3 again. In here, use constant runtime. How do I do constant runtime? And it could be like an even number is singled out, right? So this one doesn't even work. Like the sum of this is what? 10. Right? The sum of this is 10. And then as we go through, I don't know. What the hell? What is the trick for this? I mean, we cannot sort, right? Sort is O and log n and is constant extra space. But if we sort, is not linear time. Right? So I'm stuck. Right? Either linear time with linear extra space, a counter, or sorting, which is O and log n runtime, but with constant extra space. But we want to do a constant I don't know. Wow. The label is easy, but I actually have no idea. What is the trick? I mean, we can solve this. I mean, solving is not the issue. Right? I think solving we can just call counter on nums, and counter has dot. Counter has a, I forgot, counter. Counter has a function called, what's the function? Most common, right? The most, wait, they don't have least common? Oh, they don't. They do not. So, all right, and then that shall be it. But this is not, right? This is on time, but on on space. So not following the requirement, not satisfying the requirement. So it's unfortunately, this one will pass, but it does not satisfy. Or, right, we can do O(n) log(n) time, but O(n) log(n) time. Yeah, we should change this to O1 space, but O(n) log(n) time. Basically, we say nums.sort, right? And then we say for I in range 1 to len nums, we say if nums I is not equal to nums I minus 1, then break, and we're going to return nums I minus 1, right? Huh. Okay, I equals 1. While I is smaller than len nums, I plus equal 1. Invalid syntax. I forgot to add this. Right, yeah. If it's equal to the previous one, I just go. If it's not equal to, oh, hold on. If it's not equal to, shouldn't we just return I? Yeah, let's just start with 0. Right, if it's equal to, I move. If it's not equal to, it will be this. Yeah. The first time that's not equal to. So smaller this minus 1. If I is not equal to this plus 1, then I break. Right? If it's not equal to that, I can return nums I. If it's the first value, we will get out. If it's not, we'll have here this not equal to this. Oh, hold on. Nope. Actually, no. No. I plus equal to 2. Right? Like if it's equal, if the first one is equal to the second one, then I will plus equal to 2. Right? If it's equal or plus equal to 2. If it is not equal, yeah, that should be right. Plus equal to 2. Yeah. As O1 space with O(n) log(n) time. How do I get to O1 space? I mean, Can we do a sorting with O(n) time? No, we have bucket sort, but those are not O1 space. What the hell? I don't know. We'll find a single number, right? So everybody else is doubled up. Hold on. What if I find the sum, and everyone I encounter, I double it? Hold on. This might be an idea. What if I find the sum of everything? So 2, 2, 1, right? 2, 2, 1. If I find the sum of 5, and then when it goes in, so 2 times 2, 2 times 2, 1 times 2. This one will give us 4, 4, 2. Let's give us 10. Okay? Yeah, 2 times 2, 1 times 2, then I know, right? But everybody is times 2. Yeah, still, because the ideal is if I have the sum, right, and then if everyone I can just multiply by 2, if just this one multiply by 2, everybody else do not multiply by 2. Multiply by 2. And then the result is the same. Two multiplied. It's like, how do I know as I traverse through? And I already counted it. What if I do this and everyone remove a once equals to 5? Yeah, that is just the sum. That doesn't mean anything. Okay, let's say plus 2 plus 2. What if I have 3? If the sum is an odd number, right? If the sum is an odd number, then the single value must be even. I mean, the single value must be odd. If the sum is an even number, then the single value must be an even number, right? So sum is 5. So every time we encounter an odd value, we can just remove it. Even number, we can remove it. So we can go through, remove all the even values, okay? So in here, remove all the even values, we remain 1. Then we can count how many is remaining, right? Remain 1. Then what if I like 2, 2, 1, 3, 3? 2, 2, 1, 3, 3 is 11. right? So I remove all the even values. That gave us 1, 3, 3, which add up to 7. We still don't know. It's a 7, all right? And then we have doubling on all the odd numbers. And yeah, it's still not working. This is still not working. Well, I have doubled up on the odd numbers. How do you differentiate? I don't know. This one got me. This one got me. I need a hint. Related topic. Bit manipulation. Ooh. Bit manipulation. Similar questions. Bit manipulation. A bitmap? No way. Really? Exclusive OR. Exclusive OR. Because this exclusive OR this is 0. This exclusive OR this is 0. And then these exclusive OR are all 0. So we just need to exclusive. Oh, come on. You are not serious. Really? That's we can use reduce. Right? Or accumulate. Yeah, let's do it a stupid way. So that's just the start, right? No, actually, nums 0, and then for I in range 1 to land nums, rest exclusive or nums I. Yeah, why you do that? Why you make it harder on yourself? And then return rest. Nope. Wait, it doesn't work. How? 0 exclusive or... Oh, because I forgot to do this. Come on. Come on, man. Come on, man. I have 2 minutes. Let's go. Let's get this one done. There we go. Ay. Now we got it. We have the hint. Exclusive or. All right. So yeah, I'll code this one up. I'll also use reduce so I can do this in one line. All right. That will be it for today. Yeah, we got lazy today. 3 easy questions, but this one is actually quite challenging. I don't know. I didn't know. I'll see you guys tomorrow. Adios.